Yep. So cycling movements in animals, such as locomotion, heartbeat, or respirations, are believed to be governed by neural circuit, or a central pattern generator that generates timing in a feed-forward way. But if we look around, clocks are governed by mechanical oscillation. So when you say it is governed by a neural clock, we say there is a jumble of neurons and a certain combination of them is producing a nice timing. And if we need to produce another frequency, that can be done by engaging other set of neurons. But if we use a neuromechanical oscillation, things can be simpler. So basically, simpler neuron is producing a rhythm based on a moving mechanical part. And for another frequency, you can just use a smaller or bigger body part. So which is better, neurons alone or with a body? So we tested some prevalence, also tested some accuracy, and we will discuss about some dynamics underlying it. About the prevalence, we brought some subjects into the lab and asked them to keep time at a given metronome beat. And then here is what they did. So they were asked to imagine, let's imagine that the metronome would go away at a certain point, but you want to maintain the rhythm. So what will you do? Observation here is that people wanted to move something, even though I explicitly told them that you don't really need to move something if you are not in that mood. But people always moved something. And that something seemed to be depending on a frequency. So is it more accurate to move the body? Maybe. So here is our testing. We gave an audio cue, and a subject moves some body part at a given frequency and reports every 5 beats using isometric contraction of finger. And we measured that with EMG sensor. And at certain point, the audio cue goes away, but the subject keeps moving at a given frequency and still reports every 5 beats. So if we see the whole testing record, it is from one subject. So we can see the time between each spikes and then define that as report interval. And if we plot it over time, it looked like this, where this one was target interval. So it was with the body moving. We can do the same thing, but without moving anything. And here is the result for that from the same subject. So seems to be time was messed up a lot more here. So we calculated RMS error compared to target interval and had more subjects to test it. And the result over different frequency looked like this. So it was more accurate to move a body part. So about some dynamics. So we observed that maybe people move more mass for lower frequency, but usually, what's going on? Well, the subject was moving like this in this video, so it's not easy to measure how much mass was moving. So we used force plate and motion. So at given frequency, people moved. And then we used amplitude of the force and amplitude of the motion to figure out the effective mass like this. And then we saw that people were using more mass for lower frequencies. So it seems like people know how to adjust their movement or how to adjust their moving body part to produce rhythm at various frequencies. So people prefer to move something. It's more accurate when they move something. And then people know how to move kind of optimally. So yeah, final question. Maybe we need to think more about using feed-forward neural clock to generate cycling movement, especially when there already is a moving part.
Great. Thank you. Yeah, way in the back. Do you have a mic back there? There is one.
So for the subjects to report when they thought the beat was, they're say they're not moving, they're just counting in their head to 5 beats and then they tap. Is that how it works?
So when they are reporting the time without any body part, you mean?
Yeah. If they're not allowed to move and they're just reporting the frequency, they're tapping with a finger every 5 beats.
So when they are not allowed to move, we really wanted to eliminate any movement. So we used isometric contraction of thumb. So have thumb like this and then press it without really moving it.
Okay.
So we measured EMG.
But it was every 5 beats?
That actually depends on the beat frequency. So we tried to maintain the beat report interval to be approximately same. So for some beats, we made them to report every 3 beats, and some 4 beats it was every 10 beats when it was high frequency.
So you varied between 3 beats and 10 beats, and it depended on the. So what I wonder, so in Western music, usually beats are divided into 4s.
Oh yeah.
Sometimes 3s.
Yeah.
And so I wonder if you're counting to 5 in your head and you're used to Western music, that might be harder to counting to 4 or maybe 3. So I wonder if there's an element of this study of seeing is, if we ask the subjects to return every 3 beats or return every 4, every 5, you might actually see a difference in their accuracy. Especially, and that might also depend on their musical training. And I wonder, have you thought about that? Is that an avenue you're going to go down? What do you think?
Okay, that's a good question, and we've thought about that. And I think there is an effect based on how often you report. And actually, I haven't thought about it as maybe 4 is easier. But I think in general, it's easier to report more often than reporting, say, every 20 or 30. It's really difficult. So we tried to not go over 10. We didn't make subjects to count over 10 to reduce the effect of counting. But we think that there is an effect. And I think in general, it becomes more difficult to report more bits. But we still need to test that effect.
Okay, we will take one more burning question.
Oh, mine's not that burning. It was more of clarification. So.
One more burning clarification.
I just wanted to clarify, in your experimental protocol, did you restrict what types of movements they could do when they were doing movements, or with what body parts, or did you just let them do whatever?
Okay, for the accuracy test, we didn't constrain anything, but we asked them to have 1 cycle per bit, so something like this is not allowed. But people could select the movement they wanted. But we also tested constrained body parts, like asking them to only move your finger or only move your whole arm. But we found that people usually cheat with that. Even if they are asked to move only finger, they are slightly moving something.
Yeah.
So we need more tests for that.
Did you see like a wide variety of strategies, or was there like a specific strategy that was consistent And like, how did that affect how well they performed?
You mean, did I see if
So like,
many
if
people
some
chose
people
the same
always
movement?
tapped their foot
Uh-huh.
versus people who always tapped their finger or whatever, did that affect how well they performed? Like, was there any sort of correlation between strategy chosen and
I
results?
saw many people tend to use their hand, but I don't know whether that affects the accuracy of the movement. But for me, it seemed like tapping foot was less accurate than tapping with hand.
All right, in the interest of time and lunch, we need to keep going. So let's thank our speaker one more time.